Good morning. We are going to learn to calculate both what an enteral nutrition order provides and what someone should have, given case examples. In the first example, we see a patient who is on a tube feeding order of osmolite 1.0, and the order says 60 mils per hour continuous. It doesn't give you a route. This could be NG, OG, it could be through a PEG tube, but we know that it's going continuously on a pump. To calculate the total volume, we'll assume that it will be for 24 hours. And so we multiply 60 mils per hour times 24 hours in a day, and we get 1,440 mLs total volume. To determine the free water provided by the formula, you will need to look up the percentage water on the formula. Osmolite is an Abbott product. If we look it up on the Abbott website, you will see that the nutrition information is reported for a serving size of 8 ounces, and that it also tells you that 8 ounces is 237 mils. The water is reported as, quote, 199 grams per mil. That's not possible. It's a mistake on the website. It should actually be telling you that it's 199 grams of water in the serving size, 237 mils. To get the percentage water in that formula, you divide 199 grams of water divided by 237 mils, and multiply that by 100%, and you get that the formula is 84% water. If you multiply 84% by the total volume you calculated above, 1,440 mils, you get 1,210 mLs of free water. So that's the water that's available for use by the body for fluid needs. To determine the total calories, you need to determine the calories per mil. Now, osmolite is a standard formula, which we think of as being a 1.0 cal per mil formula. However, Abbott is an American company, and so they tend to use ounces in their cans. And so if you look on the website, it actually tells you there are 250 calories in a 237 ml can. Thus, to get the calories per mil, you take 250 calories in the can, divide by the volume in the can, because you're trying to get calories per mil, so you do the same order in your division, and you get 1.06 kcals per mil. To determine the total calories that your formula is giving this patient, you multiply the 1,440 mils times 1.06, and you get 1,526 calories. To determine total protein, you can do it a couple of ways. You can either determine the protein per liter, or you can determine the number of cans that the patient will get. So to do it the first way, you take 1,000 mils, which is, right, the volume in a liter is 1,000 mils, divide by 237 mils, or the amount in a can, and you get 4.2 cans in a liter. And then on the website, it tells you that there's 10.5 grams of protein in one can, so you do 4.2 cans times 10.5 grams of protein per can, and you get 44.3 grams of protein per liter. You could even break that into grams of protein per mil if you wanted. But 1.44 liters, 1,440 mils, is the same as 1.44 liters times 44.3 grams of protein in a liter, gives you 64 grams of protein given to this patient. If you did it the other way, you would take the 1,440 mils, divide by 237 mils in a can, and you'd get 6.1 cans total volume for the patient, multiply by 10.5 grams in a can, and get 64 grams of protein. Okay, so in the second example, we're trying to determine what a patient actually needs. I've given you an example of a pretty simple patient. Mrs. Garcia is 70 years old. She's 65 inches tall, and she weighs 155 pounds. She has severe Parkinson's that's progressed to the point where she can't take in sufficient calories by mouth. She's shaking a lot. It's not well controlled with medication, and so she really isn't able to feed herself much or control things well. And so she's had a PEG tube placed, and you were consulted for her tube feeding. So I give you these details. She is, we said she was 65 inches and 155, so remember to convert 155 pounds to kilos. I take 155 divided by 2.2, and she weighs 70.5 kilos. And then remember her weight, her height was 65 inches. And so if I multiply that by 2.54, I get that she's 165 centimeters. If I go ahead and calculate her BMI, she's 25.8, which means she is classified as overweight, right? But we don't have a special energy estimation formula for our overweight patients. It's really more for obese. So I can either estimate her needs using 25 kcals per kilo, which would give me 1,762 calories, or I can use the Mifflin St. George formula for a female, get her REE, multiply that by 1.1 for the thermic effect of food, multiply it again by 1.2 because I assume she's sedentary, and I get 1,623 calories. For fluid, because she's 70, in other words over 65, we would probably not, if we were going to use the kcals per, mils per kilogram method for estimating fluid, we probably wouldn't use 30 because she's older and they tend to have a lower fluid need. Also, she's probably indoors a lot and sedentary, and so 25 mils per kilo is fine, which gives us the same as the quick method above, 1,762 mils. And then if we estimate her protein needs, I would say 0.8 could be appropriate, which is just the RDA for older adults. You could use 1 if you think, well, that RDA underestimates and she needs a bit more. You could even use up to 1.2, but you probably wouldn't do more than that. Then you'd want to consider, does she need to have a bolus, a continuous, or intermittent tube feeding? In her case, bolus would probably be most appropriate. She doesn't have any contraindications. Her age makes her slightly at an increased risk for aspiration, probably her Parkinson's, her neurologic condition. But since we assume she's going to be upright living, she's not at a greatly increased aspiration risk. And so bolus feeds would be more physiologic and allow her more ability to move, less time tied to a pump and things like that, and receive therapy. So a bolus tube feeding is probably the most appropriate. And when we're considering the type of feeding, a standard formula that contains fiber, again, is probably most important. Standard, because we can't think of a reason why she needs a pre-digested or elemental formula. We can't think of a good reason why she needs to avoid fiber. In fact, she may need it more because people with neurologic conditions sometimes have differences in gastric motility, and fiber can be helpful. And so we then calculate the order. So we know, let's say in this case, we use 1,760 quick method, and we know that Jevity has 1.06 calories per mil, 44 grams of protein, and is about 80% free water. Then we take 1,760 calories recommended divided by 1.06 calories per mil, and we know she needs 1,660 mils per day. Let's say we decide, due to her usual eating pattern, maybe she eats 3 meals and a snack, and we think she has good gastric emptying, that we might go over the usual bolus of 400 mils. The usual bolus is probably 200 to 400 milliliters. But we go a little bit higher, 415 mils, or about 14 ounces. And we decide she's going to get that at 8, at noon, at 4, and 8 p.m. Well, we've estimated her order, we've decided it's going to be bolus, but then we want to back calculate to make sure we did it right. So we take her 1,660 mils, multiply by 1.06. We're like, yep, she's going to get exactly 1,760 calories. Then we take her 1,660, multiply by 80%, determine she has 1,328 mils of free water. And then we take her 1,660 mils again, convert it to liters, multiply by 44 grams per liter, and determine she's going to get 73 grams of protein, which will meet her estimated needs, right? Her estimated needs were 71. She's going to get 73. And then we'll determine the fluid difference and give her extra fluid. Once we subtract the free water she gets from formula as a bolus 4 times a day. That's really just 3 ounces of extra water at the feeding. But she may not need fluid boluses. She's probably on a medication regimen, and they may give a little bit of fluid before and after that. And that is all.